All right. While we worked through this section, we never actually did a slant slope. And all the slant slope is we actually have to just divide, okay? And so what happens with the slant slope is we have the numerator has a higher power than the denominator. And so to do that, we just take 2x plus 1 divided into, and we have 24x squared plus 6x plus 0. So we have to remember to add that 0 in there. All right, so 2x goes into 24x squared how many times? Well, that looks like it's going to be 12x. And so we multiply that, that's going to give us 24x squared, and then plus 12x. Now, remember, subtract, so that minus that's going to give us 0. 6 minus 12 is going to be minus 6x, and then bring down our 0. Now we multiply that times what to get the negative 6? We'll have to multiply it by negative 3. So that's going to give us a negative 6x, and then it's going to be minus 3. And so now, again, we subtract that minus that 0. That minus that's going to give us 3. And so what happens is we have that left over a little bit, our remainder, but what we get as our slant slope is equal to y equals 12x minus 3. So that's going to be our slant slope, okay? What about the next one here? Same thing going to happen. We're going to have to plug in this time an x in the middle. So we have a 3x minus 2 into 81x squared plus 0x minus 18. 3 times what is going to give us 81? Well, that's going to give us a 27, and it's going to be an x. So it's going to be 81x squared, and then it's going to be minus 54x, x, and that can be our parenthesis. Subtract. That minus that 0, that plus that basically is 54x, and then bring down our 18. And so you have to multiply 3 by to get 54. That's going to be 18. So plus 18. That's 54x. And then minus 36. Subtract. That's 0. That's plus. So that's going to give us 18. And so here our slant slope is y equals 27x plus 18. Okay. So that was what you would need to do if you had to actually have the x squared in the numerator is higher than the x in the denominator. So that's when we do that. And so, most of them we saw on previous examples were, something like x over x squared or x squared over x squared where they equal, and then you just use the number here, or you said it was equal to 0y. Okay. All right, so let's look at the next one here. So what we're supposed to find are x and y intercepts, vertical and horizontal or slant asymptotes, and then sketch our graph. All right, so what are we going to have? Are we going to have a horizontal slant or what? Well, in this case, if we notice, we have x squared over x, and that's what we saw here. So that's going to be a slant in this case. So instead of a horizontal, we'll have a slant asymptote. And so let's go through and kind of find everything we need to look through. So let's go ahead and change this. Can we factor this? I don't know. Let's see. So it's a 2x, x. Factors of 20 are usually 4 and 5. We can't put a 4 here, so let's put the 4 here. Let's put a 5 here. So that would be 8, and 5 would be 3. So we want a negative. So that's going to be a negative here and a positive here. So that's going to be minus 8x plus 5x is minus 3. That's minus 20. That's 2x. So that looks good. And then x minus 5. All right. So our domain is going to be all reals except x equals 5. So that means our vertical asymptote is x equals 5, which is going to have a multiplicity of 1. And with multiplicity of 1, we'll have that asymptote. So we'll have something like that or something like that. Okay. Now, Let's see here. We have to do the division because this is going to be uh, the slant asymptote. And notice we have this set up. We could do synthetic division this time because we have x minus 5. Remember, if we have x minus k, we can do synthetic division. And so we're going to take 5 into 2 minus 3 minus 20. So bring down our 2, that's going to be a 10. Add those, going to be 7. That's going to be 35. That's going to give us 15. And this will be our slant. And so that's going to be an x. And so it's going to be y equals 2x plus 7. That's going to be our slant asymptote. Okay, so that's going to be that. Do we have any intercepts? So let's look at our y-intercept. And so we'll have x equals 0. If we have x equals 0, we have 5 times minus 4. So that's going to give us minus 20 over a minus 5. So that's going to give us a 4. And so 0, 4 is going to be our y-intercept. That looks good. Now, if we set those equal to 0 up here, 2x plus 5 and x minus 4 equals 0, we'll get 4 comma 0. And if we subtract that, we'll have a minus 5 over 2 comma 0. So those are going to be our x intercepts. And again, just setting our numerator equal to 0 gives us our x-intercepts. All right. Now I think we should have everything we need. Now this one's not going to be so easy because we have that slant asymptote. So we're not just going to have a nice vertical or horizontal line at some number. We're going to have some slant. And so we're actually going to have to number things and get our points. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we have a vertical at x equals 5. So 1, 2, 3, 4, 5. Okay. And then we have another one at a slant at y equals 2x plus 7. So at 7, 1, 2, 3, 4, 5, 6, 7. And so we'll have that point. And then we're going to go up to, so we don't have enough. We should have had less in the denominator, it looks like, but that's okay. Let's go a little higher. 1, 2, 3, 4, 5. So we can, now where did our point go? 1, 2, 3, 4, 5, 6, 7. We can go down 1, 2, left 1, and that would be about there. We can go up 1, 2, right 1. And so, we're going to have some kind of something like this. And again, this is going to be a little harder because you have that slant asymptote to draw, and so we didn't take into consideration everything. We should have maybe even made these by 2s instead. That could have brought it down half as much, and we could have got it into our graph better than being way up here. All right, so now let's maybe draw and peach this time. And so we have 4, well, maybe let's make our dots in black though. That makes it so we can see them a lot better. So we have 4 0. So we have 1, 2, 3, 4, 0. Minus 2.5 0. 1, 2.5 0. We have 0, 4. So we have 1, 2, 3, 4. And I think that's about all we have. So our vertical asymptote is going to have something, I think it's going to probably look like this one, because it looks like with this, we have these points here, and they're going to be within those asymptotes. Okay, so now how does it actually look? That's going to be a question. So it's going to come up here something like this, and then come down something like this. And again, it's rough. I know I hit my 3 points, and after that, we're just estimating. Now, because this asymptote's like this, that means I'm going to have to come down from here, and I'm going to have to come over like this one, because it's going to have the same thing with this. It's going to have going one way on one side, going the other way on the other side. And so that's going to be how my overall graph is going to look. And so it sketches a graph. Now it doesn't say, what to do. It doesn't say, as the end behavior or anything. It just says sketch a graph. So my kind of peach colored thing is kind of my rough sketch of this graph with all the items we found. So, these are all pretty set in stone. This is pretty set in stone. Everything else, my rough sketch, that's what it's called. It's called a rough sketch. We just sketch in the graph. It didn't say specifically draw it out exactly. All right, so what about this one? Okay, well, this one's kind of nice. We're supposed to, again, sketch the graph, but it factored everything. So we're supposed to find our x, y intercepts, our vertical, horizontal, slant asymptotes, and then sketch. All right, so our domain is going to be all real numbers except, and it's going to be except this one, and this one. So except x equals 3, x equals -1, and x equals a -4. Okay, so those are also going to be my vertical asymptotes. So if we say vertical asymptote, that's going to be x equals 3, x equals -1, and x equals -4. Okay. Now, what do we have also? Well, we have some x-intercepts we can also get pretty easy, and we got the y-intercept we can get pretty easy. So the y-intercept is going to be x equals 0, and then y equals, well, we're going to have 2 squared times a -5 over, now we'll have a -3 times a 1 times a 4. Well, 2 squared is 4 times -5, so that's a -20. Then we have -3 times 4 is -12. And so we reduce that. It's going to be positive. Let's see, 4 will go in that 5, 4 will go in that 3. So we'll have a 0, 5 thirds. Okay, so that looks like our y-intercept. Now our x-intercept, let's just do that up here. So we're going to have multiplicity of 2 for this one and 1 for this one. Okay, so multiplicity of 2, multiplicity of 1. But our point's basically going to be, our intercepts are going to be x equals -2 and x equals a 5. So that's going to be a -2, 0, and that's going to be a 5, 0. But again, that is multiplicity of 2. So what happens when we have multiplicity of 2? It bounces off, whereas multiplicity of 1, that goes through. Okay, so this is kind of going to bounce off that axis, and this is going to go through the axis. All right, so what else do we have? Okay, we have a third power here, a third power here. So those are equal, and so our horizontal asymptote is just going to be y equals 1, okay, because we just have our coefficient, and that's just 1. All right, I think we have everything we need now to draw this in a rough sketch mode. All right, so let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. And how far do I need to go out? I think I've got as far as I need to go here. So horizontal asymptote at y equals 1. So we have this one. That looks good. Vertical asymptotes x equals 3. X equals -1, and x equals -4. So that's 1, 2, 3, 4. All right, kind of roughly done there. Now we have intercepts. -2, 0. Let's put these in black so we can make sure we notice them. -2, 0, so that'll be 1. And we'll have 5, 0. So 1, 2, 3, 4, 5. And we got 0, 5 thirds. So that's 0, 1, and 2 thirds. So, somewhere about there roughly. All right, so now we have about everything we need, I think. So let's draw some lines. Let's do green this time to be different. Now, we know when we hit this one, the -2, 0, it's multiplicity of 2, so it comes back down. So we have to stay within those asymptotes, and we know it just hits it and comes back down. Now, all of our asymptotes, those are odd. And so what do we know about that? That means we're going to have, it's going to have our asymptote, and it's going to either be like this, or it's going to be like that. Okay, so with this one, we can start right away, and we say, well, that's going to come down, and it's going to come here, and it's not going to go through that. It's going to just come down here, and then it's going to come back up like that. Okay, now this one was up here, so it has to be down here, and so it's going to come up here. Now this one had multiplicity 1, so it's just going to go through that point and then get really close to that asymptote. Now this one had to be odd, so this is going to come down, and then it's going to come close to that one. So now we've got all the points hit. We've got, multiplicity of 2, so it bounces off. This one just goes through and comes back up, and this one goes through and hits that. And so that should be our rough sketch of this graph. Again, we found all the points, and then after that, we kind of drew what we had from there, and that's how we went through and found that one. Okay. So what do we have now? Applications. All right, so a right circular cylinder. So let's draw that first. Doesn't look the same, but that's okay. Has a volume of 40 cubic inches, so volume is equal to 40. X is the radius, so this is going to be our radius. Okay, so that's going to be the X, and we have some kind of a height. We don't know what the height is here. So what is a volume of a right circular cylinder? So remember, it's going to be volume is equal to pi r squared h, or in this case, it's going to be the x because we're using x as the radius. We know the volume is 40, and so we have 40 equals pi x squared times h. I'm going to guess that we're going to have to solve this for h because we're going to have to solve that for something because it says we're going to be doing some kind of a surface area here to get the wrap around it and stuff like that, because it's going to be 1 cent per square inch to construct the rest of the cylinder. So I'll solve that for h and say, well, that's going to be 40 over pi x squared. Okay. Now, what are we thinking about? It says it costs 4 cents per square inch to construct the top and bottom. Well, that means this part and this part is going to be so many cents. And then it's going to cost 1 cent per square inch to construct the rest of the cylinder. Well, how do we figure this out? So we know that the area of that circle is pi r squared. And then our sides, that's going to be how we calculate that. And so we need to kind of figure out how to calculate sides. Now, do we remember the circumference? Because our side is, if we cut like down one line, it's going to end up being something like that, okay, where we're going to have our height, and then when we unroll it, depending on how long that is, that's going to be that circumference of that circle. Okay, so that's the circumference of the circle. Well, what is the circumference of the circle? That's 2 pi r. So we have to remember that. So area of this is going to be basically C times H. Okay. All right, so now we know C is 2 pi r, so area is equal to 2 pi r h. Now again, we're using r is x, so we're gonna have to kind of remember r's or x's, because sometimes I'm using r, sometimes I'm using x. So it would have been nice if they would just said use x is equal r is equal to radius, but they didn't. But that's okay. And so now we have to figure out this surface area and this surface area and this surface area. Okay. So surface area is going to be equal to, let's not put colon. Well, we have a surface area of two things. We have two circles, so we have two of those. So that's going to be 2 pi r squared. And I should have used x, but I went ahead and used r because it's what we use. We're just going to have to remember to go back and forth at the end. And then we're going to have plus 2 pi r h, okay, because that's going to be this surface area, but we need everything in terms of r. So, here we plugged it in as x, but, let's go back and let's just put everything as r, and then at the very end, we'll just remember it's going to be actually the x, okay? So this was 2 pi r h, but h was equal to that. So then we have 2 pi r squared plus 2 pi r times 40 over pi r squared, okay? All right, so now we need to cancel. So let's do some cancellation. It looks like one of those r's cancels one. That pi cancels that pi. Now we can multiply that, divide by that. And so let's go back to our green again. And so now we have 2 pi r squared plus 2 times 40 was 80 over r, okay? All right, now it says, because we have to consider prices now. So it's 4 cents per square inch to construct top and bottom. All right, so that's going to come into play here. So we're going to have to actually take and multiply this times price, because we're going to have the surface area for a price. And so that's going to be 2 pi r squared times 4, because that's the area of the circle, and that was 4 cents per square inch. And then plus 80 over r times its price. Well, it was only 1, so that's just 1. Okay, so that's going to be 2 times 4 is 8, so that's going to be 8 pi r squared plus, and then that's just times 1, 80 over r. All right. So that is going to be the formula we need to use, and we want to minimize the cost, okay? And so what we need to do now is we need to plug this function we just found into our calculator and minimize it, all right? So what we've done is I've already plugged it in there, and I went back to using x's because we have to use x for this. So it's 8 pi r squared plus 80 over r. And so now we look at the graph of that. Okay, so that's a pretty cool graph. And so now we need to minimize, and so we'll do a 3. And so let's maybe move over, I don't know, there's our left bound. Maybe that's our right bound. And so it says our R minimum is 1.1675, so maybe 1.68, I would say. So it says R is approximately 1.168, and we're in inches. Okay, so that's roughly that. So that's what all it asked for. It just said find the radius. It didn't say find the height or anything, but that's going to be our radius. to minimize the cost. Now, let's say it did say find h. So h is equal to 40 divided by pi times 1.168 squared. And so let's type that into the calculator on the side here. So 40 divided by pi times 1.168 squared. And so that is going to give us roughly 9.333 inches. Okay, so let's get rid of some of that scratch there. Okay. And again, that's only if they ask for it. Now, does that all right. All right, so that would be what our height would be if we wanted to minimize it. So again, all they asked for was this value, and so basically with that, we're done with the problem. All right, so that's all I have for this section. So hopefully that helps.